Hello everyone, you are welcome to the GMAT 41 Support Student Education Initiative Program. In this video, I'll be teaching you number system. We're going to learn about different bases of counting, and of course, in the course of this topic, we are going to also see how we can convert from one base to another base. In this topic also, I'll be teaching you how we can carry out certain operations on number bases, such as addition, subtraction, and multiplication. On the board here, we have a short introductory note to this topic. I'd like us to look at it. Now, on the board, we have the definition of number base. A number base is simply a system of counting in which certain units make up a bundle. Certain units make up what? A bundle. And when you get to any particular bundle, that bundle forms a new place value. So take note of that. Number base is simply a system of what? Counting. And in this system of counting, certain units make up a bundle. This bundle forms a new place value. Just as a quick one for you to understand the concept of number base. When you're counting your natural numbers, 1, 2, 3, 4, 5, 6, down to 10, you would observe one pattern once you get to 10. That 10 forms one bundle. Because if you go back and then start counting from 11, 12, 13, when you get to 20, you still have a bundle of 10. For every new bundle you get, it is a new place value that you're introducing into your counting. Just think about this. When counting from 1 to 10, after 9 you get to what? 10. From 10 you go to 11, 12. You would agree with me that from 11 is as if you are repeating 1, 2, 3. Let's look at it. 11 is 1, 1. 12 is 1, 2. 13 is 1, 3. You notice something in the pattern. The first digit is always 1. When you go to the next digit, it's as if you are repeating your 1, 2, 3. So you have 11, the number at the back of that 1 is 1. 12, the number at the back of the 1 is 2. 13, the number at the back of that 1 is 3. Can you see the pattern, right? So one can really look at this and say, wow, it's as if counting from 1 to 10, 10 becomes like a new starting point. Alright? Which means that once you get to 10, it's as if that is 0. You are ready to now start all over, counting again from 1. Just think of when you get to 20. You will observe that same pattern. 20 is as if you've gotten to the end point. So you're now getting ready to start counting again. So you have something like 21, 22, 23, 24. You notice that the first digit in each of these numbers is 2, 2, 2, 2. The number after the 2, it's a repetition of 1, 2, 3, 4, 5 in that order. So that is actually a system of counting. Generally, we count in base 10. You know that. Because our normal counting is from 1 to 10, 11 to 20, 21 to 30 in that order. That base 10 counting system is also known as decimal or denary. That we have on the board here. Decimal or what? Denary. Does that mean that we only count in base 10? The answer is no. We have other bases of counting. Can count in base 2, can count in base 3, base 4, not base 9. Even more than base 10. Alright? Now, if you're counting in base 2, for example, you have 2 as your end point. So it means you're now preparing to start all over again. Am I communicating? If you're counting in base 2, you have something like 0 and 1. 0 and 1. You can't get 2 in that base 2 you are counting. The reason is this. That 2 is like your end point, which prepares you to start all over counting again. So if I have 0, 1, that 2 terminates my counting. So it will not appear in base 2. That 2 will now become 0. Then if you go to 3, 3 will now become 1. Because they're counting in twos. That's the point. 0, 1 are the twos there. So if you go to 2, 3, that 2 repeats 0 and then 3 gives you 1. If you go to 4, you've already gotten a bundle here. So if you go to 4, 4 now is an end point which prepares you to start all over again. So you have 4 to be 0, 5 to be 1. So you can see the pairs of 2 going on in that order. Alright, now when we are counting in any base, it is important for us to know that the highest number you can get in that base is simply 1 less than the base you are counting in. When counting in any base, the highest number or digit is always 1 less than the base itself. That's just what I explained over here when I was talking about base 2. Alright? In base 2 you have 0, 1. You can't get 2 because the highest number in any given base is always 1 less, smaller than the base you're counting. Take for instance, when we are counting in base 10, the highest possible number in base 10 is 9. You are not allowed to record 10. For you to understand this clearly, let me ask you a question. Imagine you are doing addition, because our normal addition is in base 10 generally, what we do. When you add something like 5 plus 5, maybe you have, let's say 25 plus 15. You start with the unit part. 5 plus 5, you get 0. You get 10 rather. You are not allowed to record that 10 under the unit part. You record 0 and move 1 to the tens place value. Now when you get 13 in your addition, maybe you have something like 26 plus 17. From the unit part, 6 plus 7 will give you 13. You are not allowed to record that 13. Okay? You record 3, you move 1 to the next place value. The highest number you can record under any place value when calculating in base 10, we all agree that it is 9. Is that not so? You can record 9. If you have something like 27 plus 17, okay, 27 plus 12 rather, 27 plus 12. 7 plus 2 under the unit part, you get 9. You can record that 9. But if eventually it hits 10 and above, you can't record that number under that place value. You record something and carry over another digit. As we move on in this topic, we are going to see why we do that in mathematics. And actually, what did we do that led us to recording a particular digit and then moving the other to the next place value. Alright, so the note on the board here says more. Like this, you're counting in base 10. So you start from 0, 1, 2, 3. The highest number is what? 9. You can't go more than 9. You can't have 10 when counting in base 10. What about counting in base 2? Base 2 is also known as binary base or binary system. Is that okay? Now if you're counting in base 2, the highest digits you can have there is 1. And 1 is 1 less than 2. Just like 9 here is 1 smaller than 10, which is what I explained already. So if you're counting in base 2, you can only have 0 and 1. 0 and what? 1. You can't record 2 when you are solving a problem in base 2. It's not allowed. Okay? So here I have this note that when counting in any base, that base itself is taken as a new starting point, 0. I said that earlier, is that not so? You're doing your addition in base 10, for example. Once you add any 2 digits or more than 2 digits and it gives you 10, you can't record that 10 because that 10 is like your starting point now. So you take it to be 0. Then you move over another digit, just like we do it in normal calculation. The same thing if you are solving something in base 2, and let's assume that I give you 1, 1, which is maybe say 11 plus 11. That's 1, 1. I said solve that in base 2. You know that 11 plus 11, in the unit part you have 1 plus 1. 1 plus 1 will give you 2. You can't record 2 there since I told you to do the calculation in base 2. All you need to do is to do certain form of little mathematics there, because that 2 you got eventually becomes 0. You carry over something. We're going to see that when we handle operations on number system. Is that okay? So we are now going to see how we can convert from base 10 to any other base. We want to see how we can convert from base 10 to other bases, and of course from other bases to base 10. In this video, I'll be explaining how we can convert from base 10 to any other base. To convert from base 10 to any other base is a simple process. Is that okay? All we need is just the knowledge of division. But let me say this quickly. To be able to divide easily, you need a good knowledge of multiplication. This reminds me of one of my videos long time ago, where I stated that multiplication is the boat of crossing mathematics bridge. Alright? So I am using this opportunity to encourage you friends to make sure you practice the multiplication table, learn it very well. It really doesn't matter the level we are, alright, as long as we know it. So you can practice it, please, it's going to help you. Quickly, how do we convert a number from base 10 to another base? On the board here we have a short note explaining that. All we need to do, the new base we are converting to, use that new base to divide the base 10 number repeatedly. You will continue that division until you get 0 remainder, a certain number. Alright, that certain number, don't worry, when we solve question, you will understand what I mean by that certain number. But you must get to that point, 0 remainder, that certain number. That is the last point of your division. Now, at each point of your dividing, you are expected to record the remainder you are getting. Let us quickly demonstrate this using this example on the board. Now we want to convert 9 base 10 to base 2. So what do? I'll just create a column like trying to solve LCM. But of course, it is not lowest common multiple that we are solving here, please. Take note. These are the columns, alright? This 2, 2, 2, forget about it first. This is the column you have to create. You create this column for this 9 because you are converting 9 from base 10 to base 2. So 2 is a new base. You have this 9, you have a column for remainder. Then you start. Start with 2. Use this 2 to divide this 9. 2 can go into 9 4 times. The remainder will be 1. If you go to 2 times table, you will notice that 2 times 4 will give you 8. So it will be left with 1 as the remainder to complete the 9. That remainder, you record it under this column. Alright, we've gotten 4, remainder 1. We move on again. Use 2 again to divide. 2 can divide this 4. How many times can 2 go into 4? It will go 2 times. You record the 2 here. The remainder will be 0. The reason is because 2 can divide 4 and there will be no remainder. 2 can divide 4 completely. If you go to 2 times table, you would see that 2 times 2 will give you 4. So it can divide it completely. The remainder will be 0, meaning there is no remainder. Alright, we've gotten this 2, so we move on again. I'm going to use this 2 to divide this 2. 2 can divide 2. If you check in 2 times table, you would agree with me that 2 can go into 2 1 time. This is the 1, you record it down there. There will be no remainder because 2 can divide 2 completely. No remainder. So we record 0 as a remainder, meaning nothing, that there is no remainder. Alright, then we move on. At this point you have 1 here, so we're going to use 2 again to divide that 1. But hey, we want to be very careful here now. 1 is less than 2. So 2 cannot divide 1. 2 cannot divide 1 completely, cannot go into 1, giving us whole number. So what do? This is where we now record 0, the remainder will be 1. So see that thing I told you, keep dividing until you get 0 remainder, a certain number. In this case of this question, that certain number is 1. Quickly before we pick our answers, let me explain why this is 0 remainder 1. Remember, I divided this 1 by this 2, and we said that the answer is 0, the remainder will be 1. Think about this. I have 1 orange. I now send 2 persons to go and share the orange and divide the orange. But they are not allowed to cut the orange. You know, cutting it now means you have fraction. I sent them to go share this orange with the mindset, with the thought that they can share this orange. Maybe they will pick it either 1, 1 or 2, 2, you know, like whole numbers. Question. If these 2 persons go and then they see this 1 orange, can they share this 1 orange amongst 2 of them without cutting it? Can they pick it as whole numbers? It's not possible. They can't do that. So what will happen? You'll have to come back to me and say, oh, sorry, we couldn't share the orange. It could not go round the 2 of us. So they'll leave the orange there. Come back to me empty-handed. That empty-handed now is the 0 here. Means they did not share it. So you have 0. They couldn't divide it. So like here, 2 divide 1. It's not possible. You have 0. What will remain? That 1 orange will still remain there. So the remainder is still that 1. We'll bring it down here. At this point, we are now going to pick our answers. So what do? Remember, on the board here I said that to get the answer, you have to collect all remainders from bottom up. That's why I showed this arrow here, from bottom up. Look at that. So we'll go to the remainder column, pick 1, 0, 0, 1, you know, from bottom up. Therefore, 9 base 10 is equal to 1, 0, 0, 1 in base 2, and that is the answer.